Good afternoon. And thank you for joining, everyone. And we do have our speakers here, Dr. Newton and Mr. Wondwesen. Both will present a showcase for the project they did on data collection. We will have a presentation of 15 to 20 minutes each, and then we will open the floor for the discussion, question and answer at the end of the session. I think we are ready. So we have Dr. Newton. He's holding a bachelor in soil science and master in geoinformatics and a master in information system management. And he's a soil and a geospatial scientist, a specialist in soil information and data science for with more than 15 years.
All right, thank you very much. My name is Newton Nyapwere. I'm not yet a doctor. I'm still pursuing my doctorate, so I'm not yet a doctor. I have a bachelor's in soil science, a master's in geoinformatics, and another master's in information systems management. As already been mentioned, I work for FAO Global Soil Partnership under Land and Water Management. So we have a project, a flagship project that we are currently carrying out in Central America and Africa. So in Central America, we have Guatemala and Honduras, and in Africa, we have Ghana, Kenya, and Zambia. But we have made advances in Guatemala, Honduras, and Zambia. In Kenya and Ghana, we are still working on the logistics. So in terms of this project, it's called SoilFER, soil mapping for resilient agro systems, where it is funded by the U.S. Department of State, which will end in May 2027. Our main aim was to create a global crop decision support platform, as well as creating a land use planning at farm level, and as well as strengthening institutional framework, as well as creation of crop models that are helpful to farmers. So this project falls under the flagship division for adapted crops and soils, that is VAX, which is which is funded by United States State Department, where SoilFER falls under these 4 pillars or this decision framework, where we ask about where do we put our plant, or where do we plant in terms of the promotion and support of land use, and increasing understanding of variability and degradation, risk and production potential, and climate change effects, as well as to improve soil maps and develop and disseminate soil information. Then what to plant is basically about the crops that we are going to that are going to be used, but mainly those nutritious crops which have been abandoned, but of indigenous crops which have been abandoned, but which are of high value in terms of climate change resilience. Then we also have the water management system that is for efficiency and productivity, where we are trying to promote adoption of integrated management systems, including tillage, weed, and pest management, as well as fertilization, and also how to apply based on local conditions, where we are trying to look at the hyper localization of these crop management decisions for farmers, as well as to enable farmers to adjust management practices at the subfield scale. So this project, it resonates well and is fully compliant with the Nairobi Declaration. As you are aware, there was the AFSH symposium, which happened in earlier this year in Kenya, where all these declarations, except for tripling fertilizer production and distribution, they also fall under the project that we are currently working on. So in terms of what we intend to, what we are looking at, we are looking at on the national companies, we are looking at the data, we are looking at the information and knowledge, then we are also looking at the action. So in terms of data, that's where we are looking at the soil sampling campaign and harmonization and collection of soil gas data and soil analysis, where we are also capacitating soil labs in those countries. Then we also have national soil analytical database, as well as spectral libraries that we are going to develop based on the data that we collect in the field. Then we are also going to build the national soil information systems, as well as laboratory information management systems. Then in terms of knowledge and information and knowledge, we have national nutrient and nutrient budget maps, so property maps, and decision support tools and systems for fertilizer and management. Then the action that we are looking at is the fertilizer decision support for farmers and governments, as well as decision support for crop suitability, including opportunity crops, which are under VAT, and capacity development and outreach programs, as well as socio-economic and financial and cost-benefit analysis for fertilizer and sustainable soil management. So the process that we are going to take is very simple, where we are going to collect information. We are going to collect information in the field using the local expertise. For example, in Zambia, we are going to work with a local soil research partner, where we are going to collect land cover or land use, and we're also going to collect soil food parameters, as well as farmer surveys, where it is going to be combined with the information from the lab, as well as legacy data that we are also compiling to create a national soil information systems. And ultimately, we are going to create farmer applications that can be used by extension officers, by farmers right in the field. So in terms of the soil properties that we are going to collect under the project, we have information from the lab analysis, which includes organic carbon, total carbon, and CEC, including total sulfur and boron. Then in terms of the from soil observation or from direct from the field, we have limited parameters that we are collecting because we are going to collect quite a number of samples. So some of the information that is going to be collected, that is going to be analyzed in the lab, we limited so that we do not collect it in the field. So we only focused on those parameters that are going to be used for creation of models for land cover, land use. So these parameters that we are going to direct collect in the field is soil depth, that rockiness, drainage clash, soil erosion, surface cracks, and soil color. So in terms of soil color, we are not going to use the mass of color. We are only going to have the qualitative assessment, so that we try to move as fast as possible in the field. Then we also have indirect measurements that we are going to derive from the lab analysis, as well as soil observations. Then besides the soil sampling exercise, we also have the profiles that we are going to open across the country. As you will see in the next presentations, how we are going to collect the soil samples as well as the soil profiles. Then I want to just check the case study of Zambia, because that's where we have advanced in terms of the preparation for the field work in the coming weeks. So basically, Zambia, contributes about 19% of the GDP. And it is estimated that there are over 1.5 million small-scale farmers in Zambia, and over 20% of which are headed by women. And this year, there's been a drought, and Zambia declared the ongoing drought as a national disaster. So this has exacerbated acute food insecurity in 72% of the country. So in terms of the work that we are doing there, we are targeting to collect approximately 5,400 sampling sites, or to visit 5,400 sampling sites, where we are going to collect soil samples in two depth, that is 0 to 30 and 30 to 60. So we are going to collect in 70% of the cropland, and 25% where we have grasslands, and 5% in forestry. So in terms of the sampling design, which will inform how we are going to collect data in the field. So the sampling design is basically based on the factor spatial variation using the Scopan model. As a soil scientist, this is a very important model that we use when we want to give relations in terms of how the soil behave at a specific location. So in terms of the environmental covariates that we used to come up with the sampling locations, we have the climate, where we have temperature, precipitation, evapotranspiration, wind, and growing season. Then in terms of, we also considered soil climate, where we also looked at the cumulative annual precipitation, then soil water holding capacity, and other properties such as soil temperature regimes and soil moisture regime classes. Then we also used the vegetation indices for us to be able to pinpoint where we want to take our samples. So we had the NDVI in different periods of time, but they were ranging from 2000 to 2022. Then we also had the fraction of photosynthesis active radiation is the covariates, different covariates that we are using. Then we also looked at the terrain or the topography, where we looked at the different behavior of the terrain that include profile curvature, downslope curvature, slope elevation, and so on. Then we also included the soil legacy data, the data that is already available, so that we do not oversample those areas that already have data which has been analyzed and the data is available. So we had about 4,419 points that we also factored in the model for the soil sampling design. So this is the distribution, the map that you see on the left side of those points. So the eastern side has been, some work has been done, quite a lot of work that is those points which are clustered there. So we also had, in terms of our final map, we also had very few points there. Then in terms of how we determined the sampling, the number of samples or the number of points that we were going to utilize within the Zambia context, we used the total variations of the covariates, as I've already said. Then we also used the Quebec labeler divergence, where we were looking at what point can we add some points for analysis without having any significant change. So, but we also included also the project constraints, of course. But in terms of just using the cubic nebular divergence model, we realized that at 1,000 sampling points, it was the minimum that you can be able to distribute the points across the country. But the optimum was 3,500 sampling points. And after that, there will be no significant change in terms of the output of the product. But of course, this was also based on the resolution of the covariates that we are using. In this instance, we are using those data sets which are of mostly at 250 meter resolution. But in terms of how we were going to do the sampling design distribution, we used principles where we clustered we used the hierarchical random sampling at 3 levels, where the highest level was looking at a primary sampling unit of a 2 by 2 kilometer grid. So this, we had 3 land use classes, as I've already said, that we had 3 land use classes. In each class, for example, the land cover, then we have those primary sampling units, which are a 2 by 2 kilometer grid. And within that 2 by 2 kilometer grid, we have specific secondary sampling units, which are within a hectare or 100 by 100 meters. And within that, we have 4 targets as secondary sampling units per each primary sampling unit. So these 4 targets are the ones that the teams in the field will go and try to collect samples there. Then we also have tertiary sampling units, which is the last level, where it is the actual point where we are going to collect the sample. So each secondary sampling unit have got a single target sampling unit. And we also have replacements in case the teams will not be able to reach for some reason. Maybe there is some barrier, maybe there's a river where they could not cross, or maybe the farmers were not able to give consent to the teams who are in the field. So if they fail to reach that point at each and every level, from PSU to SSU to TSU, then they have to have some replacements. So in this case, for replacements, we designed in such a way that for a 2 by 2 kilometer grid, we will have 1 replacement PSU, which have equally the same properties or the same behavior as the target PSU. This also applies to the secondary sampling units, where we also have 3 replacements. So for 4 target ones, we will have 3 replacements within the 2 by 2 kilometer grid. Then within the secondary sampling unit, we also have 2 replacements in case when you reach the area that you want to, when you reach the point that you want to sample, then maybe there is a situation where you will not be able to sample. Maybe there is a termite mound that will not be a representative. So you have to move to the other 2 replacements. Then this is just an illustration of the sampling units. Like we have already said that the primary sampling units here at the left part of this big square is a primary sampling unit. So within those primary sampling units, we have the soil sampling units, which are at 100 by 100, that is a hectare. And within those secondary sampling units, we have the tertiary sampling units within the soil sampling unit. So this is the outcome of the soil sampling design when we did when we did run the model, where we came up with 5,404 sampling locations, which translates to 10,808 samples. because we'll be collecting at 0 to 30 centimeters as topsoil, then subsoil will be collecting at 30 to 60 centimeters. Then we also have profiles, 478 profiles that we are going to collect, and assuming that we have 5 genetic horizons, we will have 2,390 samples. So all in all, from croplands at 70%, pastures at 25%, and forests at 5%, we will have 13,290 that we are going to collect for this project. So this is just the distribution of the points, the final points. That is the target points for each land cover or land use. That is in croplands, we will collect 3,708, and in forests, we will collect 272. And in grasslands, we will collect 1,352. So in terms of navigating to for how we decide on the soil sampling, primary soil sampling unit and secondary soil sampling unit. So this is just a diagrammatic illustration of this decision that the teams can make when going for data collection at the end, at the lower level, that is the TSU, the tertiary sampling unit. So the first thing that the surveyors should do is to proceed to the first secondary sampling unit within the primary sampling unit. So when they reach there, they will ask, they will decide whether the site is suitable for sampling. If it's yes, they can then proceed to collect soil samples. Okay, they should. Sorry, when the site is suitable, then can the soils be collected within that area? Maybe it's not possible because of other issues, such as maybe there's a continuous rock there, which will not be possible to collect samples. So if it's yes, they can collect samples. Then they can collect samples, and they complete the software collect form. That is the form that we have designed collect a mobile data form that we've designed to collect information in the field that will be used by surveyors in the field. But if it's no, then they will just report in the form and then go to the next replacement or the next TSU or SSU. But if it's a yes, they are collecting samples, then they will be asked, have you sampled 4 SSUs within PSU? If it's yes, then they will proceed as they would have completed. But if it's no, if there are any other SSUs, they will proceed and go back to selecting another SSU. So basically, that's what the process should happen when the teams are collecting information in the field. So in terms of soil sample selection at the tertiary sampling unit, or at the point where we want to collect information, we will collect information at 4 sites. That is R0. R0 is the point where we have our coordinates, the GPS coordinates, where we were navigating when we want to find that place. So, so in terms of other areas that we are going to take samples, we will move about 2 meters in the northern direction, and then in the diagonal side, 2 meters, which will assign P1, P2, and P3. So all these locations will be sampled, and it will the samples that have been collected in each specific site in each specific depth will be then put in a bucket and mix it thoroughly so that we collect one composite sample for each depth. For example, for one TSU, it means that we'll collect 2 samples, but we would have collected eight of them and then mix them 4 in each bucket, so that we have 2 samples, that is topsoil and the subsoil. this is the one that will then label it and send to the lab. Then in terms of the soil profile data collection, we are also planning to collect 478 profiles. This is with the goal to extrapolate taxonomic features from soil profiles to other locations. And we only collect the most representative soil landscape areas. So, but we also do the full profile description. Here we are going to follow the all the procedures in terms of the full profile, that is all the horizon designations, all the roads, density, everything that every information that is relevant to the soil information system. Then we will do the usual soil classification system, where we are going to classify soils based on the FAO or WRB 22 soil classification system. So in terms of the field data capture, we like I've already highlighted, we designed a CoP toolbox based mobile data collection tool that we have christened SoilFER Collect, where field surveyors will go and collect this primary soil and land cover data from the field. So it has two distinct modules, and the other one, we'll add the other one for farmer surveys, make it 3. But for now, we have 2, that is the soil, for the soil parameters, those 5 parameters that I have already highlighted, as well as the land cover data that is going to be collected for each site that we visit. So the data can be captured offline and seamlessly sent as soon as there is internet connection with the mobile device. So what are our expected outputs or products? So we are planning to have national nutrient budget maps. We are also expecting to have national soil property maps and crop suitability maps. Then we also expect to have fully integrated national soil information system and decision support tools and system for fertilizer, crop, and other management practices. So the outcomes basically is maps for improved understanding of database and maps of soil resources at national and field scale. Then decision support tools for farmers and decision officers. These are digital tools and solutions for improved natural resource and fertilizer management. Then there is also an outcome about capacity building, where governmental institutions are strengthened and empowered in the state-of-the-art soil analysis and data management. Then ultimately, we also need to improve yields as outcomes, where farmer capacities are raised for improved fertilizer use, crop selection, and sustainable soil management. So that brings to the end of my presentation. Thank you very much.
Thank you, Mr. Newton, for the interesting presentation. I myself have a couple of questions, but that will be at the end of the session, of today's session. So thank you very much. And I would like once again to ask our guests to either post your questions to Mr. Newton on the chat, or unmute yourself by the end of the session and ask him directly. Thank you very much for being with us today. And I would like to welcome Mr. Wondwesen, our keynote speaker, second keynote speaker for today. Hello. I would like to first give a brief introduction about Mr. Wondwesen Haile from Ethiopia. He is a soil survey and land evaluation specialist with 20 years of experience, and he participated in over 60 projects across different countries with a main focus on Ethiopia. He worked on a variety and various irrigation and land use planning projects, and I would like to give you the floor, Mr. Wondwesen, to maybe introduce yourself more if you like, and take us through your presentation. Thank you very much, and thanks for being with us today.
Okay, thank you, Dr. Crow. My presentation will focus on an ongoing study on the assessment of salinization potential of soils and irrigation waters in lower Awash Subbasin, which is located in the Afar regional state of Ethiopia. So the main focus will be the data collection part. Later, with another event, we'll share you the modeling and the other output parts. So to give you some highlights about the project is located in the lower part of the Awash river basin, which is one of the biggest river basin in Ethiopia, with a river which travels around 1,200 kilometers. It passes through almost 4 big regions of the country, where irrigation is practiced in a very vast scale. The basin covers an area of around 100,000 square kilometers, supporting millions of people. As it covers a lot of areas in the country. So I'll pass this part just to save some time. As you can see, the shaded part, the river starts from the center of the country, extends to the border of Djibouti. So our study area is mainly in the lower part of this sub-basin. So the lower Awash sub-basin is known for its arid and semi-arid climate with a minimal rainfall, which is obviously a place where salinity is aggravated. The topography-wise, the region is predominantly flat, with about 65% of the land classified as 0 to 2% slope gradient range, or almost flat range. Only around 4% of the area is steeper slope, or above 5%. So with the low rainfall amount, flat topography, so salinity is very well expected in this region. So the main causes of salinity in this region are human-induced, and the other is the natural factor, where there is a presence of saline groundwater reservoirs, fields rich with minerals, and occasional flood events further contribute to the salinity in the region. As well, in places where irrigation is practiced, there is improper irrigation management and poor drainage system, which is playing a crucial role in the salinization in the areas. So our study is, especially the study is a vast study, is to develop a strategy and in development strategy and mitigation strategy, as well to review the policy at national level and regional level. However, the soil part, because the study includes soil part, hydrogeological assessment, environment, and some modeling also. So the soil part focuses on characterizing the salinization potential with respect to soil. So it is to characterize the nature and extent of soil with those specific objective. So studying the soil will help us to spatially map the soil type in the study area. Also, it will help us to identify hotspot areas, and it will also be a database to monitor future changes over time. So with respect to the methodology, we followed 3 stages using the WRB guideline, which is outlined in Annex 1, Field Guide Standards and Procedures. So the 3 stages we followed are the pre-field work, field work, and post-field and the data analysis, which we are doing right now. So we have already completed the first 2 stages. So the main focus will be on those 2 stages. So in the pre-field activities, the first thing is the collection of previously studied data or legacy profile informations. So after that, we have organized guidelines for easy use at the field. And based on this previous data, satellite imageries, we have developed a base map for the field survey teams for them to associate the land with the base information. So we followed a grid based auger survey system. So we pre-located the auger pointers before we go to the field. So I uploaded these pointers to each survey's tablet for easy navigation and collection of data. So as part of this pre-field activities, we have developed data collection forms on CoP toolbox. So these forms include auger sampling. For the auger sampling site observation, the site observation is between 2 augers. They see some salt affected areas or exposed salts, maybe, or poorly drained areas or stones or other features were included in this between site observation. The other is the soil profile description form. I may share you. Okay. I think you can see this the form on your screen. Hello. Can you see the form?
It's the presentation.
Okay.
I think you have to stop sharing this one and then reshare the form again.
Yeah, I'll do that. Okay.
Yeah.
Okay. This is the field form developed on the CoP toolbox. So it have each profile will have an individual ID. The location of the profile it will be recorded automatically from the tablet because it integrates GPS coordinates. So the date will be entered. So the surveyor name, slope gradient, shape, a lot of features are included in this form for the surveyors to fill in the field, which is very user-friendly and easy to go around. So for each layers, once they describe the surface features, all these are the surface features, they go to each layer. So they will record the depth for each layer, and then describe these parameters based on the the guideline, the WRB Annex 1 field guide. Okay, let me go back to my presentation. So accordingly, we developed all these three forms on compatible box.
Can you, Mr. Can you put it? Yes, it's correct now. Thank you so much.
So we distributed and provide training for the surveyors on these forms, how they are going to fill. And then we also developed a short version of the field guideline. So they can refer the guideline when they need more details. As part of these pre-field activities, we organize field equipment and logistics. It's just to show you all the processes in the pre-field activities, like any other field activity. In the field, we did the field work in two phases, the soil augering part, and after that, we conducted the soil profile description part. So before we do any soil profile description, what we did was on all those grid pointers, we try to collect the soil auger description part. So the soil auger description was done to 1.2 meter depths, unless it is stopped by rock or water table. So we did the augering for one observation to represent the 250 hectare, because the study scale was 1 to 250,000 scales. So we followed the WRB guideline. And then while we do augering, we excavated a mini hole, which extends about 40 centimeters, just to see the profile development is at the auger level. Then they continue the remaining depth by the auger. So at each layers, the boundary of the distinct layer, the color of the layer, texture, class, consistency, presence of coarse material, and other features were recorded. Based on that, at field level, we characterize these features to a new unique soil type. So by classifying that, we provided, we develop a code from every day's survey results. So they will record that soil unit in each soil augers. That will be later used for locating soil profile pointers. So these are some photos from the auger survey. Like I told you, we do a mini hole like this before we start the augering. So from the mini hole, the surveyor can observe the development of at least 1 or 2 layers. These were the soil auger pointers, but as you know, it's a challenge to cover all the study areas. So we were unsuccessful with some of the pointers. Mainly is due to road access. So there is a limited access road in the project area, so we were not able to cover all parties. In fact, most of these pointers were done by walking, so it was a very challenge. So if it is above 10 or 12 kilometers with the hard climate situation, it was hard to access some of the pointers. The other problem was there is a big dam in an abandoned irrigation activity in the area. So some of the drainage, canals, and there is a poor management of this irrigation infrastructures, which led to, which created some wetlands, and we were not able to access those pointers too. So we were successful with this auger pointers. So from each auger pointers, we gave a designated course like this L1 to L7. Those are loamy soils, mainly cambisols and fluvisols. So these codes are developed based on other features. If it says L, it means all the auger profile is loamy textured soil. If it says clay, it's clay textured soil. If it says CL, it's a clay over loamy. If it is LC, it's loamy over clay. So this will later will help us in the classifying the soil to different RSCGs. So after we've done this, completed the auger survey, what we did is we developed polygons with same soil types. We developed these polygons with the same soil types and located in this auger pointers a profile description point. So we later developed the soil profile description in these areas. So in these selected areas, we excavated soil profile to a depth of 2 meters to have the complete picture of the soil profile. So almost nearly we've done 60 profile pits, which we planned to achieve 10% of the auger descriptions. So these are some sample profiles we've done in those areas. From the soil sample side, what we've done is we have organized a temporary field lab in the field because it's the city is on salinity, so we were able to analyze the soil samples for electrical conductivity and pH at field level, because the both test meters are portable. So from each auger point, we've been collecting 3 samples from 0 to 30, 30 to 60, 60 to 100 centimeter depths. So we air dried these samples, we crashed in the field, we organized the field lab technician teams. So we have analyzed these samples for easy water and pH at field level. So these have been a help for the locating the profile pits. You know, the number of profiles are so limited, so we've tried to, represent these profiles for all the city areas. However, for the soil samples taken from the profile pits, we've done it from 0 to 200 centimeters for each layers. So those samples were brought to the capital, Addis Ababa. So they were analyzed for full parameters because we are going to characterize the soils fertility-wise too. So this is some photos taken during the field EC and the pH measurements. So we've tried hard to, to make it possible. So I have explained a bit about the CoP toolbox. So we have used CoP toolbox for all the data collection processes. So these advantages have been, I think, they are all over the website. So you can refer the advantage of the CoP toolbox from there. But with our situation, it was very helpful for real-time data synchronization. It is offline capacity for remote access, because most of this in the city areas, there was limited access of internet, so they record their data on their tablets. So when they go back to the field base, so they will upload the data to the cloud. So centrally, the project was led by the Ministry of Agriculture. So the team will have the access for each day's data. So if there is any gap or any error, we can inform the surveyors to correct that immediately and avoid further errors. So it have a good GPS accuracy. So GPS is integrated in the system, so they won't spend a lot of time, like they do in the papers. So in its every aspect, it's a very good tool for such kind of studies. So there will not be a data entry process once they uploaded the data. So you can download the data in a CSV Excel format, so you can process it immediately. So it will save a lot of times. So if they lost the device, the data is on the cloud. It's another advantage of the CoP toolbox. It also supports photos, notes, and additional media are integrated in the system. So that was very helpful for us, without going to the site. The surveys provided every information for us. So we were able to visualize everything in their database. So it was a very good tool for us because I've done another assignment in the same area, was like 18 or 19 years ago. At that time, we were collecting data by paper, so the difference is too much. And then we were very helped by this toolbox. That's why I just try to emphasize this one, because in other projects, this exercise was not yet started. So it's my advice. So I've seen the differences. So for all of you, I advise you to have a look on this toolbox for your future assignments. So this is a sample from the form. I have already shared you the original profile form, so I think we don't have to go through this. And if some of you are not familiar with soil survey activities, it's just to share you what challenges we faced during the data collection, especially in the field phase. The first thing in our study area was there was a limited or poorly maintained roads. It makes a very tough challenge for the surveys to reach specific points, and often they were pushed to walk a long distances, which will slow down data collection, or you have to increase the number of surveys, which makes the project very expensive. And the study area is also associated with dense vegetations, so it was hard to travel some tracks, and then they were pushed to, reroute to reach some other locations. I have already mentioned this. There were some waterlogged areas which created a lot of troubles for the surveyors. In fact, it was in an arid or the hottest place in the country, so that was a challenge. There was also a challenge of infrastructure supporting the area. This is to show you our surveyors' challenges, how hot the climate is, these waterlogging problems, dense vegetations in the area. They have to travel like that, and then they have to, jump on some obstacles. As you can see, the vegetation, it was very challenging for them, and then they've done a great job in achieving this assignment. So I hope we'll have some other session to share you the final result of this project in a different event. And this is for today. Thank you.
Thank you very much for the very interesting presentation and nice picture to imagine how it is challenging for this data collection in the field. It's really nice to see. Thank you very much for being our keynote speaker for today's event. And I would like to move for a 5 minutes short presentation about our CoP by one of our CoP ambassador. Eric Asamawa, can you please start unmute yourself and give us a 5 minutes short presentation, and then we will move to the question and answer session. Thank you very much.
Okay, thank you very much, Crow, and thanks to our presenters for today. The CoP, the Soil Data and Information Community of Practice, is part of the flagship initiatives under the National Soil Information System program being coordinated by ISRIC, together with the Resource Library for Soil Information Producers. And it has 7 main work streams, which is data collection, laboratory analysis, soil archiving, data organization, modeling and mapping, applying soil information, data and info 7, which centers around the soil information user consideration. A brief background about the CoP started in May 2023 with 126 members, and now it has grown to 700 membership from 42 African countries. Currently, there are 16 ambassadors from 11 African countries, and the vision of the CoP is to share ideas and strengthen each other's work, collectively guide discussions and professional development, innovate for soil information system development, and co-develop standards for all soil information workflow steps. The goals are knowledge sharing, foster collaboration and networking, education and capacity strengthening. And to achieve these goals, the CoP embarks on the following activities, which includes showcase events, joint publication and reports, trainings, and regular interactions via communication and networking platforms of the CoP. To become a member of the CoP, you can scan the barcode on your screen, or also from the ISRIC website. The address is on your screen, and also you can follow up for more interactive discussions and information from the LinkedIn page of the Soil Information Community of Practice. It also has a resource library for information sharing. It includes tools, tutorials, books, guides, and other resources to help through the soil information workflow steps, as we have already talked about. To get access to the resource library, you can use the address resources.isric.org, or you can scan the barcode to get access to the resource library to have access to all the tools and tutorials that is available on the platform. Thank you for your attention. Crow, I give it back to you. Thank you.
Thank you very much, Eric, for the short presentation about the CoP. I may open the floor now for our audience and guests to please ask our guests the question you like, or just post it on the chat and I will coordinate it. Thank you very much. We do have a question from Ashinafi. Yes, please, Ashinafi.
Okay, thank you, Crow, and thank you. First, I would like to thank those presenters and for the excellent presentation they did. Yeah, so my question goes to the first presenter, Mr. Newton. Thank you for sharing us, your experience for the SoilFER project. And I was wondering, if you would elaborate a bit more on the soil analysis procedure they are planning to implement for both auger and profile samples. Are they the same with chemistry procedure or different? Because in one of your slides, I saw that we are planning to determine soil texture based on USDA classification procedure, I would say. And again, for the profiles, I think we are planning to implement WRB 2022. So if we take, texture determination for both procedures, I think they differ a bit. For instance, if we take, the sand diameter determination is a bit different. So, so it's I would appreciate it, if we elaborate a bit more on the soil analysis procedure we are planning to implement in the initiative. Thank you.
Thank you, Shinafi. Mr. Newton, would you like to address the question?
Thank you very much. It was a bit breaking. Maybe it's my internet, so I did not hear clearly. Maybe if we could just post it on the chat.
Yeah. Ashinafi, can you write your question in the chat, please? Because of the bad networking, so bad signals, perhaps it will be better. I think we do have another question from Eric. Eric, I saw your hand up. Don't know if you have a question.
No, Crow. I realized my question was asked, so I think it's okay. Yeah, thank you.
I have a question myself to Newton until we receive the one from Ashinafi. You mentioned in your first slide about the data collection and in your last slide also as outcome that you would like to have an integrated soil information system on a national level. I would like to know what is your definition for the soil information system and what this outcome, the integrated one, would look like. Can you explain a little bit so we can understand what kind of a system you are aiming to? Thank you.
Okay. So the soil information system that we are planning to have is basically the. Am I clear?
Yeah.
Am I audible
Yes,
enough?
I can hear you. Yes.
Okay. So the soil information that we need to have is basically to do with because the first thing that we have is soil legacy data. Because you realize that in most countries, especially in developing countries, they have paper maps. They have even if they have those shape files or maps that they've done, they are not in a centralized system. So we want to get this information in one place, and also that we also need to have the fresh collected information that we are going to produce, those soil property maps that we are also going to integrate it into the National Soil Information System. Fortunately enough, we are also working with ISRIC, especially for Zambia, because they also have a project there. So we are working in collaboration, and I'm sure that the soil information system that also need to be produced by ISRIC is also the one that we are going to work together. So yeah, so even when we went there in February, we also had a team from ISRIC where we were trying to harness or to collect soil legacy data and also to see how best we can work together in that regard.
Which project, if I may ask? The one that you are collaborating with ISRIC?
Space to Place.
Oh, yes,
Yeah.
sure. Yeah.
Mhm.
So basically, the system you are mentioning here in your presentation as outcome is a system for legacy data and new data points.
Yes.
Yeah, okay. So it's like because at ISRIC and specifically in the committee of practice that is coordinated by ISRIC, we are trying to spread the awareness and the education about what is all the elements of soil information system. So you may notice in presentation by our ambassador Eric, we had the workflow consists of 7 elements all around the soil, around the user consideration, but the data collection was part of it. So the whole system that is we are talking about at ISRIC is a system that has 7 elements, and data collection, including legacy data, is actually a first section of the system. So I wanted to see what kind of system you are aiming to, and is it like complete system like the one we branded here at ISRIC, or is it specific one? So yeah, thank you for answering. I think we do have the question now by Ashinafi. He says, elaborate a bit more on the soil analysis procedure on the auger and profile samples.
Yes. Thank you very
Similar
much
to,
for the question.
yeah.
So basically what we doing is we have two approaches in terms of how we are going to collect data. So the first exercise that we are doing is to collect those samples from the 5,400 points that we have already alluded to, where we are going to collect using the auger from 0 to 30 and 30 to 60. Then like I have said that when you reach a point, the point which we call tertiary sampling unit, because we said that we have a hierarchical 3 levels that we are going to use when we are approaching the sampling points: the primary sampling unit, the secondary sampling unit, and the tertiary sampling unit. So when you reach the tertiary sampling unit, you then have your first point within that tertiary sampling unit is RS0, and then you also mark other 3 points at 2-meter interval, and then from there you then start to auger for 0 to 30, put in a separate bucket, 30 to 6, put in a separate bucket for those 4 points, and then you then mix it to get a composite sample that you then sample to the lab. Then in terms of the profiles, we are going to open the soil profiles, right? Maybe up to 120 or 150. We are still, for this one, we are still under discussion on that. But we are going to open profiles, about 400 something profiles across the Zambian landscape, where we are going to fully describe these profiles. In terms of the depth, because we want to also do we will be doing digital soil mapping, right? So we have just intervals, for example, 0 to 30, maybe 30 to 60, 60 to 100. That approach which will enable us to do digital soil mapping rather than traditional soil survey that has always been done. So basically, that's what we plan to do for both this sampling exercise, which is the bigger one with 5,400 points, then the soil profiling, which has got about 400 profiles. Yeah.
Thank you very much. I hope this answered your question, Shinafi. If not, you can follow up and post in the chat any further question you have. And Eric, would you like to unmute yourself?
Yes, I have a follow-up question to Mr. Newton. I want to know, considering the total number of sampling points you envisage sampling, that is 5,400 points and over. How many points do you feel you can sample in a day? And also for the soil profiles, you talked about 400 soil profiles. Realistically, how many can you also do fully open, describe in a day?
Okay, thank you very much. From the training that we did, and also from the last experience, in terms of the number of points that can be covered, we put it at an average of about 1.5 PSUs. That 2 by 2 kilometer grid. It has got 4 points, which means if it's 1.5, it means the teams can cover 6 points, a minimum, an average of 6 points. So then this will depend now on the distance between those sampling points, and also, there's also issues to do with talking to the landholders or the gatekeepers. But the average that we have is about 6 points. That is 1.5 PSUs per day. But they can go up to, they can have more or less, but this is just an average. Then in terms of the soil profiles, also was this one, we are in the initial stages of designing it so that we can also see the distribution in terms of where the points are. But generally, for you to describe from previous experience, for you to fully describe the profile kit, it can take between 45 minutes to 1 hour for each profile. Yes. Depending on the complexity of that profile, but usually it's 45 to about an hour.
Okay, so Mr. Newton, so for the soil profiles, you can do you can do 5 in a day or more?
Yeah, it's possible. It's not. It may not. It may be possible or not, depending on the distribution. But it can be possible if the points are not very far away. Because you find that for this type of for this type of surface, the points may be very far away from each other. So most of the time, it will be spent on traveling from one side to another. So we can say yes, it can be 5, but I don't think it will be more than 5. It can be 5 or less, depending
Okay,
on the.
okay, thank you. I have a follow-up question also. Most of the time we forget to record the metadata about the data that we collect, and I didn't see any of the presenters highlighting the metadata they would be collected. Maybe I might be wrong, but if you are going to collect metadata, what metadata do you seek to take in addition to the core data sets you envisage to collect? Thank you. I think both presenters can help me out. Yeah.
Maybe if you can elaborate further in terms of metadata, maybe I did not get it clear. Can you elaborate a bit?
Okay,
I know it's
so
metadata about data. So at what point is it? Are you trying to refer to in terms of metadata?
okay, so the metadata, I would give some examples as who is collecting the data, the date, the time,
Okay. Yes.
the location,
Yes.
some critical information we sometimes neglect or we think they are not important and don't record them.
Okay, yeah, so
Which,
sure. Thank you very much. The COBO that we have with the name SoilFER Collect, the first information that we have on that mobile data collection tool is the name of the landholder
okay,
and their consent. They have to sign as well, including the surveyor. They have to put their name, or it's a drop down.
yeah,
We put a drop down so that they can select their name and also sign. And then there's a whole lot of information in terms of the location, in terms of district, from the province, cascading up to the district level. So that information is also there. And then in terms of the dates, the COBO, we have designed it in such a way that it captures the date of the survey automatically, and also even the time that has been spent working on the filling the form. It is also captured there. So once it comes to the server, you can just get all the information that you want from that application. Yeah.
Thank you very much, Mr. Newton, for your answers. And I don't know if Mr. Wondwesen, would you like to add something to this metadata question that addressed both speakers, please?
There's another. Sorry, there's another question that I'm seeing on the
In the chat.
chat. Yes.
Oh, yes, that's for you. What challenge do you face exactly from community while you're digging
Yes.
profile bits? Yes.
Yes. So in terms of so last week we had we had a workshop in Zambia. So we went to the field and we were simulating what they are going to do in the field. So like a demo. So we had to go through the whole process from visiting the landholders, the gatekeepers, such as the village heads. So the issue also was about their actual boundaries. Like, so for example, you want to go for one PSU with 4 points, and those 4 points will not follow the traditional boundaries. We will just follow, land cover and all the other proper those environmental coverage that we have that I've presented. So you sometimes you end up visiting maybe 4 village heads, or to notify 4 village heads, because the point is not, all the points are in different villages. So like in that instance, we had to go to one of the village heads, and then they asked about other points, and then we indicated where they are, and then they said no, in that area it might not, it's not my jurisdiction. So you also have to notify the other village head. So these are some of the challenges that can also chew up your time in the field, rather than on the actual sampling of the soils. So this is one of the challenges that we identified. And in some instances, just from previous experience, sometimes some people may not want you to work in their fields. They may refuse, especially for so profile pits, and in those instances where there's a crop which is still actively growing. So it means that we have to open up a 1.5 meter pit by 1 meter, and also remove the soils from that pit, so it can disturb their crops, and maybe it can destroy maybe 5 crops or 7 crops, which they will lose that yield. So some of them will refuse for you to work in their fields. Yeah. So those are some of the challenges that we can face in the field.
Yeah, thank you very much. Very clear. Mr. Wondwesen, you share your screen, right, for the metadata?
Yeah, just for the metadata.
Yeah.
At field level, we collect this information, we register the date, we have a specific profile IDs. The surveyor will take on his own name. So later, administrative and environmental parties are included in the database for further analysis.
Yeah. Thank you very much. I have one question for you, Mr. Wondwesen. You emphasize on using the CoP toolbar, and I wonder how easy this, as in terms of using it, like access the tool, and for any soils scientist to use it. And is it like easy to access, easy to have the license for? Is it in terms of the cost? And also, is it like easy for soil scientists in your area to use, or do you think like it needs a bit of capacity training? So I would like to know how it's possible to use it, how easy it is.
Okay, thank you. I think the mobile app version is very well easy or friendly to use for our surveyors. Almost we have arranged in another session a CoP toolbox training for about a week. So after that, before they go to the field to create consistency, we have given them a training. And you know, these days all the surveys are well with the technologies, so it was not a challenge. Acquiring a license at an institution level, it will be easy, but there is no awareness about the tool. So we use the free version. So I think if institutes are well aware, so in the future to access the tool, it is better to have enough storage for photos or other medias, you know. That was the challenge for us because we used the free version.
And what are, is there other tools that people use, let's see, and it's easy to use in Africa, for example, like comparing to the CoP?
Yeah, we used the ODK toolbox for Ethiosis project with the Agricultural Transformation Agency. I think that one is easy for the surveyors to adapt, use it, and send data easily. I think those are two tools. We found them very good, you know.
And they are very well used on a national level, you mean?
Not in many projects, you know. We insisted to create this awareness to our authorities. For ODK, they used the whole project period. I think they purchased the license. But for this one, we used the free version. But in the future, we advise, you know, to use these tools for future assignments.
Yeah, it's easier.
Can I chip in as well?
Sure, yes.
Yeah, so ODK and CoP, they are pretty much the same. It's the same application, but the only difference is the servers where you send the form. So in terms of the designing part, like for example, you design it in the Excel, when you are coding there, it's the same thing, but where you deploy it will be different. So in terms of they are pretty much the same, but for ODK, for CoP, you can use the open server that they have, the CoP server, the CoP toolbox server, which is free. For example, you can post 5,000 forms per day, which is quite a huge amount of that even for our projects, we will not post 5,000 forms per day. So it's good. But for ODK, there's their server, it will need some you need to get some license and pay it if you want to host some certain amount of some certain amount of data that you want to use. But for CoP, it's just pretty much free. Yeah.
Yeah, thank you very much. We do have two other questions for you, Newton, in the chat. One from Ashinafi again. He says, "Thank you, Mr. Newton, for your response. And my question was on the lab on soil lab analysis methods, for example, wet chemistry procedures for both samples?
I don't really understand the procedures. You mean the methods that are going to be used in the lab?
Yes, exactly. For the soil lab analysis method for the wet chemistry.
Okay, I do not want to delve much into the lab issues because yes, because we have other people who are qualified to answer those questions. But yeah, so basically the methods, the lab analysis methods that we have are just the normal methods that we've already been doing for both. For example, we are going to have the fertility part as well as the pedology part. The fertility, where we are going to analyze nitrogen, phosphorus, potassium, and other micronutrients like that list that I have already indicated. And also, then we get to have the pedological side of analysis, such as cation exchange capacity, also those derived products such as exchangeable sodium percentage and all those things. But in terms of the actual methods, I'm not really much into that, but there are some teams who are focusing on that.
Oh, yeah.
Yes.
And you both are part of the COP, so maybe if Ashinafi, if you would like to know more about how the team dealing with the samples, what chemistry analysis in the lab, and what kind of yes, please unmute yourself. Would you like to follow up?
Okay, thank you, Mr. Newton.
Yes.
Yeah, because just we faced similar issues during our previous countrywide soil survey missions in Ethiopia. So for the interest of time, so mainly we depend on MELH3 based wet chemistry for 20% of the samples, and then the project analyzed 80% based on spectroscopy, and then try to calibrate in that regard. And then if you take MELH3, sometimes the soil lab analysis requirement as per WRB 2022 is a bit different. So just I wanted to know, how you are planning to overcome such challenges, to reconcile different lab procedures. It depending on the interest of time, and also based on the requirement of some specific procedures such as WRB requirements. So we can further, discuss on these issues, to share also our experiences in this regard, maybe, in some other session. So that was my issue to I wanted to raise. And then by saying this, maybe to maybe add some points on maybe related to Mr. Wondesen's response. And thank you, Mr. Wondwesen, for really, starting, I would say, to implement CoP tools in Ethiopia. I remember, so in one event through the Coalition of the Willing, we tried to give, training on digital data collection app, and there were attempts, really to exercise using, digital data collection app for active soil survey missions, and then it's also good to know you have also started to implement in pilot project, I would say. So in line with this, maybe just to give you an information. So in our NISIS enhancement project, in line with Ministry of Agriculture and ISRIC, so one of the components is also integration of digital data collection app within the National Soil Information System of Ethiopia. So now we have reviewed, different data collection forms and apps together with ISRIC colleagues. And currently we have customized, to implement the soil survey data collection tool developed by ISRIC. And now we are planning to deploy to the Ministry of Agriculture server in this NISIS server. And then in the coming 1 month or so we are planning to really test those
templates or a digital data collection app. And then once we really have a successful testing mission, we are planning, to provide this service to any other institutions or individuals who are planning to engage, in active soil survey missions in Ethiopia. Thank you for this.
Wow, this is very nice to hear. So that you can transfer this knowledge to other national partner in your country, your area. Thank you very much. We do have another question to Mr. Newton in the chat from Mr. Asonic or Dr. Asonic Talon. He says, thank you very much. Interesting presentation. Give it a national data, and that you faced those challenges. What can you say about the representativeness of the data? Are you planning for any update to this data collected?
Yes. Okay. Thank you very much for the question. So basically, we anticipated that situation where we are going to have those challenges in terms of accessibility, in terms of some landholders refusing us to get entry. So what we did, like I've already presented, we had 3 levels, hierarchical levels in terms of the design, whereby we have a primary sampling unit, a 2 by 2 kilometer, which is also a replacement in case the teams are failed to reach that point. That primary sampling unit, they will go to another primary sampling unit. The same applies to the secondary sampling unit. We have 4 target ones, and then we have 3 replacements. So if a team failed to reach or failed to check samples at that particular SSU, then it means there are 3 other replacements that they can go with the same characteristics at the first point. The same applies to the tertiary sampling unit. When they reach the tertiary sampling unit, if they fail to reach the target one, or they fail to sample because of some reasons, then they will go for other 2 replacements that they can also try to reach or try to sample there. So that's how we tried to make sure that we maintain the representativeness of the data being collected in the field. Thank you very much.
Thanks a lot for your answer. We hope this answered your question, Dr. Talon. I think we don't have any more questions, so I would like to thank our keynote speakers for today's event, Mr. Newton and Mr. Wondwesen, for the great presentation, for the interesting presentation also, and thanks for all the audience, our guests, and for all the questions today. Thanks for your time, for being with us. Really appreciate it. I wish you all a nice evening. Thank you very much.